So now what does multidimensional scaling do? We have actually more operations on that airfield. There are 27 operations there, each having 27 bits of information about them, but that's just coincidental. And here it is. So we have very many work operations, 27 of them, each having 27 bits of information about them. And now we have to figure out how many distances are there between those 27 and 27, And so what happens is we can construct such a table. Here it is. So these are all the distances from the second operation to the third, from the second operation to the fourth, from the second operation to the fifth, and so on. So we have 27 times 27 different differences or distances. Of course, you can say that they're repeating. So its second distance to the third is the same as the third distance to the second. So half of them are repeating. Plus the distance to yourself is always 0. Okay. So it's actually something like, I think the formula would be 27 times 27 divided by 2 minus 27 divided by 2. Something like that is the number of different distances that we might have. Okay, but we're not considering the exact number, but rather the nature of the problem. So okay. So here are the distances, and remember, since each bit of airplane operations had 27 numbers about them as well, it means that we're operating in a 27-dimensional room, and all those distances, well, all in all we could say that there are 27 times 27 of them. All those distances are distances between points in a 27-dimensional room. Okay, quite hard to comprehend and imagine, as we might say. So what we're going to do is we're going to draw a 2-dimensional graph here, and we're going to put the points on that graph. Let's go to that right side here. So here it is. Here are some 2-dimensional points. Each operation has 1 point, so there are 27 points. And now what we're going to do is we're going to create a another set of distances, but these distances here on the right hand side, are distances that are forming between our 2-dimensional points. So here it is, the distances between our 2-dimensional points. Again, there are 2-dimensional points. So let me draw this out. Here it is, our nice 2-dimensional points. Here they are. And now each point will once again have a distance to every other point, which means that there are once again going to be 27 times 27 distances. So initially we had 27 times 27 distances between the two 27-dimensional points in a high-dimensional space. Now we have created ourselves a 2-dimensional picture with 2-dimensional points. Here it is. And we have, once again, 27 times 27 different distances between the points. And now this is what now the next thing is what multidimensional scaling does. It makes this left hand and the right hand distances as similar as possible. So it makes those two-dimensional distances as similar to the 27-dimensional distances as possible. It makes those two as similar as possible. And in effect, it will make the best possible two-dimensional picture. And this two-dimensional picture will show us the nature of the relationships between the operations in an airfield. This two-dimensional picture will be as good as a representation of the 27-dimensional problem or 27-dimensional initial picture as it's possible. And that's what the multidimensional scaling does.